Today we are continuing our learning of equations, and we will learn how to solve for the variable correctly today. But the first thing I want you to do is determine the sum or difference for each problem. That just means you are working them out. So I'm going to give you about 3 minutes to work out these 4 problems. Any questions? Go for it. What is the first thing I need to do to add decimals? Line up the decimal points. So I write it vertically. That's terrible 8. Okay. 7 plus 3? 1 plus 6? 1 plus 6? 7 plus 7? 14. Bring down my decimal, carry my 1. 1 plus 5? 6 plus 8? So I get 14 and 40 hundredths. Same thing with subtracting decimals. I need to line up my decimal points. 3 minus 7?
You can't do that.
So I borrow 13 minus 7. 6 minus 6. Bring down my decimal. 8 minus 5. So you should have gotten 3 and 600. What do I do to add fractions? Nope. Common denominator. What's a common denominator between 7 and 5? 35. I heard somebody say it. It's the least number that they can both multiply to, guys. What do I do to set? Can you hurry up, please? What can I multiply 7 by to get to 35? So 3 times 5? 15. What do I multiply 5 by to get to 35? 7. So 4 times 7? 28. What is 15 plus 28? 33. Try again. 43. 43. And my denominator stays the same. My numerator is larger than my denominator, so I have to simplify. How many times will 35 go into 43?
1.
1 whole time with how many left over?
8.
And my denominator stays the same. Any questions? All right, again, subtracting fractions is the same. I need a common denominator. What is the common denominator between 3 and 4? Somebody said it. 12. What do I do to 3 to get to 12? So 20 times 4? 80. And what do I do to 4 to get to 12? 15 times 3? 45. What is 80 minus 45? And my denominator stays the same. My numerator is larger than my denominator, so I need to. How many times will 12 go into 35 evenly? With how many left over? 11 out of 12. The denominator stays the same. Any questions about those? Good. We are continuing with the equation, so let's look at the next page. This is similar to what we did yesterday, except this time they're not giving you the equation. You have to look at the double number line and determine what the equation is. And there are actually 3 of them. So on number 1, you have to write the 3 equations that are represented on the double number line. Number 2, find the value of n that makes the equation true. And number 3, check your value. Make sure it is right. Any questions about what you're doing right now? So find or write the 3 equations, find the value of n for each one, and then check your answers for each one. Any questions? Good. I'm going to give you about 6 minutes. Go for it. Who can tell me the first equation represented on the double number line?
N plus 2 plus 3.
Yes. And you see it here. What is the second equation on the double number line?
N plus 5 equals 6.
Please pay attention to who I call to answer. And what is the last equation on the double number line? Cynthia? That's a plus sign. Good job. Now, we need a value for n that will make all of these true. So, what plus 2 would equal 3?
1.
So, in the first one, we say n equals 1. Yes? Okay. What plus 5 equals 6?
1.
Okay. What plus 11 equals 12? Do you notice a pattern?
Yes.
Yes, when the equations are on the same double number line, the variable should be the same. It should not be different each time. If it's 1 for 1, it should be 1 for all. Does that make sense? Number 3 wants us to check our answers. So 1 plus 2, does that equal 3? Yes. 1 plus 5, does that equal 6? Yes. And 1 plus 11, does that equal 12? Then we got it correct. Any questions? All right, let's turn the page.
Hey guys, on this page, what we're going to do is talk about how we're going to start solving these equations. So when you determine the value of a variable that makes an equation true, you solve the equation. That's what we talked about as a solution. That was one of our math terms from last time. Okay? Recall, solution to an equation is a value for the variable that makes it true. You can use the double number line to represent it, but we're also going to start learning how to actually solve it. Right? Please stop. In order to solve the equation x plus 10 is 15, we can do like we have been, set up a double number line. This time, though, my variable is not alone, is it? It has a plus 10 with it. So in order to get my variable by itself, or figure out where it actually is, I need to take that 10 and get rid of it. So I'm going to move it to the left 10 spaces so that I can find where x is. Does that make sense? Yeah. Excellent point. Good job, Bittler. So if I do that to the top one, I also need to do that to the bottom one. So when I do that to the bottom one, I take that 15, I subtract 10, and I get 5. As you guys just learned, last lesson, when I have it here, that's my equation, right? So we can now rewrite that as x equals 5. Does that make sense for everybody? Okay. If I'm going to check the solution, what do I need to do? I go back to my original equation, x plus 10 equals 15, and I'm now going to substitute the value in for x. So I'm going to just instead of x, I'm going to say 5 plus 10 equals 15. 5 plus 10 equals 15. Does 15 equal 15?
Yes.
Yeah, check. That is what your check looks like. Everybody should have that written down, right, Amari? Yeah, it's pretty much hard to do that when you're in test lab, I mean. So, which property of equality did we use for this? Subtraction, because I ended up subtracting, right? So, we used the subtraction property of equality. Are you guys seeing how all these pieces fit together?
Yeah.
Is it making sense for you? Okay.
Ask here.
Lynn, question or just rubbing your nose? Lynn? Question or just rubbing your nose? Okay. Yeah, let's go to the next page. So I'm going to give you guys a chance to prove that you're actually getting this. Remember last class, our text together. really hard for me to understand why after 3 quarters together, you're still not marking your text, but you need to. Use a double number line to determine a value. So there's our first task. That makes each equation true. Identify the property of equality that you use. There's a second task we need to do. And then we need to check our solution. So you have 3 things that you need to do for each of these problems. They've given you the base equation. Your first step, use the double number line, means I need to put that equation on my double number line. Then I'll need to move it like we did in our example we just did to show what my actual solution is. Tell me what property you use to get to that solution, and then check your answer. Any questions on what we're doing on this page? Okay, you've got 3 problems all set up for you. Go ahead and get started. I want you to work on this one by yourselves first. Try to solve it by yourself. Once you've solved all 3, check with your table mates and see if you guys get the same answer. Okay? I'll give you guys about 10 minutes to do all 3 of these. Go ahead and start. This should have been relatively easy, guys. When we're doing a double number line, whatever comes first, we normally put on top. Technically, you could do either way, but the math norm is that's what's going to go on top. So on my top, I'm going to have p plus 10. On the bottom below it, I'm going to have 17. We can put the crossbar and it shows that those are linked up. So the nice thing is that shows me very easily what I need to do to go back to where p is. So I'm moving back by 10. So if I go back 10 from that, I get 7. So I've done the double number line to find the value. Identify my property. Which property did I use? Subtraction property of equality. And our last step is to check our work. So I check my solution by starting with my base equation. P plus 10 equals 17. I substitute my value in. I said it was 7. I do 7 plus 10 and I get 17. 17 equals 17. Check. That is the bare minimum you should have had on all 3 of these. Okay? Our second one is basically the exact same. It's now 14 plus q and 32. So again, I know I'm 14 above where q is, so that's going to be somewhere down in this neighborhood. What I did was I went back 14 spaces. So I take 14 away from 32, I get 18. Which property did I use? Subtraction property of equality. And I do my check by starting with my base equation. 14 plus q equals 32. I substitute my value in. I said it was 18. I add those 2 together. I get 32. 32 equals 32. Check. My solution check. Our last one. Now they reverse the order on us. It doesn't matter, guys. I just put the 90 on top now. And my x plus 64 goes on the bottom. I now know that to get to my x, I'm going to have to go back quite a bit. I'm going back 64 spaces. So I'm coming back by 64. Meaning 90 minus 64 is going to give me 26. Which property did I use? Fraction again. Fraction property of equality. Last step, check my solution. It was 90 equals x plus 64. But I now know that the x is 26. Add 64 and 26, that's 10, 8, 9. 90 equals 90. Check. Yes. Not really, because the equation they gave me had my variable with additions.
I have questions. So like, if the head is back,
Excellent question. Let's turn the page and talk about it.
Mr. Moore, I
Want your vocabulary sheet? Yeah, a few more vocab terms for you.
have something to say, Mr. Moore.
Yeah.
I don't know. Instead of doing all of that, I just did like for example.
Talk about it.
I just think it was
Okay, guys. Here's our first one. And this kind of gets directly to what Billy was just asking about. A one-step equation is an equation you can solve using only one operation. So the key on that is I'm going to have to use the operation that they give me in the equation. So it is going to limit my choices as to which property I'm using, because what my equation states is going to tell me what I need to do to get my variable by itself. Okay? The reason that is important is our next term, which is inverse operations. Inverse operations are pairs of operations that reverse the effects of each other. For example, subtraction and addition are inverse operations. So that's why you're going to be a little limited. Because whatever my equation gives me, I've got to use the inverse operation to solve it. So whatever the inverse of that operation is the property I'm going to use. Good. Perfect. Well done. Okay. So we're going to give you an opportunity to put these into use. And we're going to start to get away from the double number line. Double number lines were really nice for introducing the concept and helping you visualize what's happening. But quite frankly, it's really cumbersome to have to do that every single time when there are much easier ways to do it. So we're going to go now into showing you those easier ways. And it starts with writing your equation out. So 8 plus 6 equals 19. Once you've written it out, here, why do you have your computer open? Close your computer. It shouldn't be out right now. Once I have my equation written, the key is being able to identify what's happening with my variable. So in this case, I'm adding 6 to my variable, correct?
Correct.
So in order to undo that, use my inverse operation, the opposite of adding 6 would be subtracting 6. But once I subtract 6 on one side of my equation, I must do it on the other side of my equation to keep my equation equal. That's literally what we did our entire last lesson, was helping you guys understand why you can do that. Okay? Once I've done that, though, I now have 6 minus 6. What's 6 minus 6? 0. So my variable has 0 added to it. And I don't know why they didn't add this, but they should have. This is actually another mathematical property. It's the additive identity property of 0. In other words, if I add 0 to any number, it's just that number. So like, what's 12 plus 0? 12. What's 4 plus 0? 4. 4. Not 0, it's 4.
Sorry, I'm thinking
Okay. What's h plus 0? 8. Does it matter what h is? No. So on this side of my equation, I now know it's just 8. On this side, when I take 19 minus 6, I get 13. So I'm now able to find my solution without having to do all the double number line work. Does that make sense?
That's what I was expecting.
Which is what you did. You have to do it on both sides of your equation. No, you don't. Because if I only do it on one side, if I do h minus 6 equals 19, and I only take away from here, h minus 6 does not equal 13. How can h minus 6 equal 19 and 13? That's using the second property default. Well, you have to do it on both sides. You can't just do it to the 19. Because if I only do it to the 19 and I don't do it to the h minus 6, you just got told that h minus 6 is 2 different answers. Is that possible?
Mr. Moore, this is what I.
No, it's not. So you have to do it on both sides. Yes, Billy.
And that was
You can.
you can just do the opposite and ask me
Yep.
what 6 equals.
So let's go through these real quick and give you guys a chance to get some practice in on this. So what is the solution to h plus equals 19? Well, we found that it was 13. How do we check our solution? I substitute that value in. So instead of h plus 6, I now say 13 plus 6 equals 19. 13 plus 6 is 19. Does 19 equal 19? Yeah. Which property that was used to maintain equality?
Subtraction.
Subtraction property of equality. Guys, make sure you're writing out the entire thing. You need to understand what the property is. Because there are a lot of properties in math that help us do what we do in order to solve it. Are there other solutions to this equation? In other words, can I use Amari's rule and say, well, h minus 6 is 19 and h minus 6 is 13? Does that work?
No. Oh wait, mine doesn't. Like his.
No, it doesn't work, does it? So is there any solution other than 13 that would work for this equation?
No.
No, there are no other solutions. The only way
You could just imagine that.
is to add 13 and 6 to get 19.
And 6.
Yes.
Oh, B. Okay.
Because it's 8 plus 6, right?
You put. Oh, that's 13. Oh.
So I ended up 1 and 3 ran together for you. Is that better, Mabel? Yes, for you.
Okay, you can't. So you're gonna say so for somebody.
Okay, guys. Now we're going to let you get a chance using the solution we just did. In other words, you don't have to do double number line. Show me how you're going to do it. Use the same strategy. Check your solution. 2 parts. So you only got 2 problems to do. We'll give you guys about 3 minutes. Let's get started. This one should have been relatively easy. Right here, here's my variable. Instead of adding 24, I'm going to do what?
Subtract.
Subtract. But if I do it on one side, I have to do it on the other. Those go away. So all I have left here is my variable. 5 minus 4 is 1. 8 minus 2 is 6. So I know t equals 61. I'm supposed to check it. So I go back to my original. 61 plus 24 equals 85. Add those 2 together. I get 85 equals 85. Check. Same thing here. Here's my variables. And instead of adding 12, I'm going to subtract 12. So if I do it to one side, I have to do it to both. 12 minus 12 is 0, so I just have my variable left here. 5 minus 2 is 3. 3 minus 1 is 2. So my equation solution is f equals 23. Go back to check it. 12 plus 23. Add those together, I get 35. 35 equals 35. Check. Questions on any of these?
Nope. No.
Okay, let's turn the page. And I actually just want you guys to go to the very bottom on this one. Go over to the box right here. I want you guys to copy down what I have written here. This is nothing, regardless of what the equation is to solve. So just give you guys a little background. When I first started teaching 2 years ago now in Germany, this was teaching equations. I thought was super easy because for me, solving equations was almost second nature. And then I gave a quiz to my kids, and they used to go miserably. So I started looking and said, okay, what am I doing wrong? What can I do to help them? It took me about 2 years to flesh this out. But once I got my students to start doing this consistently, when they were working with equations, they were able to successfully solve the equation almost every single time. That's what makes them magic. So there are a few of these steps that may not make sense to you, but please give some trust. If you will do this, you will be successful. And this is not listening. The first thing you need to do is circle the variable and draw a line through the equal sign. What this is going to do is it's going to help you focus in on the number that is with the variable. And once you find the number with the variable, then you get to step 2. You find the number with the variable and you do the opposite operation with that number to both sides of your equal sign. Again, the big key on that is you have to do it to both sides. That's all those properties of equality we've just been talking about. It doesn't matter what operation it is. When I do the opposite operation on both sides, it's going to keep it simple. Keep it easy for you. And your final step, this is basically if it's a division problem, is simplify if you need to. So for the addition, subtraction, and multiplication, when you solve, it should be in simplest form. If it's a division one, you may need to do some simplifying. So make sure you're checking your 4 key numbers, 2, 3, 5, and 7. Anybody need more time to write this down?
Yeah.
Yeah, you're like 30 more seconds. Okay, guys, if you're going to get it written down, copy it off the video or from a table mate, but we need to keep moving. So we're actually going to skip this page and go to page 420. Here is your chance to get some practice with what I just gave you as an algorithm to solve these. I'll give you a hint. Every one of these, and you can do this right now before you even start anything, you circle your variable and you draw your line. That's your first step. You can do that with every single one of these problems because it's going to help you focus in on what it is you need to move, okay? So I'm going to give you guys, you got 6 problems to do. I'll give you guys 10 minutes to solve all 6 of them. Good luck. You work with your table if you need to. I'm going to go pretty quickly because you guys should have already had a couple minutes. But I set the first 4 up for you. The process is going to be the same in every single one. We have 2 things. We're solving and checking. So the opposite of adding 120 is subtracting 120. Please stop the noise. So I'm going to take that away from both sides, meaning I have y left on this side. Do the subtraction. 5, 9, 1. Now I substitute it back in. 120 plus 195 equals 315. Add those 2 together. 315 equals 315. Check. Opposite of adding 5 and 6,700 is subtracting 5 and 6,700. Remember your rules? That means I need to line up my decimal places. Lining those up, I get 2, 2 decimal, 12 minus 5 is 7. So there's my solution. Then I go back and I put it in. 7.22 plus 5.67 equals 12.89. Add these 2 together, it gives me 9, 8, 12, 1 decimal, 1289 equals 1289. Check. Our next one, the opposite of adding 1699 is subtracting 1699. Here's one of the advantages to this system. It doesn't matter which side my variable is on. When you draw that line, it should help you very easily see which pieces go together. Okay? So I have the A equals here, and now I just start doing the subtraction. 16 gives me a 7, 14 gives me a 5, 12 gives me a 6, so A equals 657. I add those to go back to my original equation. 2356 equals 657 plus 1699. Add those 2 together, and I get 16, 15, 12, 13, 23. 2356 equals 2356. Check. Next one. And I'm going to rewrite this one over here. So 7. So actually, I'll do this in a second. I'm subtracting 1/4 from both sides. Those go away. I have G here. But I need to actually do the math on this. So 7/12 minus 1/4. First step, I need to have a common denominator. So multiplying by 3. So 7/12 minus 3/12 is going to give me 4/12, which I can simplify both those by 4. Gives me 1/3. So G equals 1/3 is my solution. 7/12 equals 1/3 plus 1/4. I'll multiply this one by 4, this one by 3, gives me 4/12 plus 3/12, which equals 7/12. 7/12 equals 7/12. My answer check. Our next one. Instead of adding 3 and 1/1400ths, I'm going to subtract 3 and 1/1400ths. Again, make sure you put in your decimal places in the right spot. I have to line my decimal places. In this case, I need to add 2 trailing zeros so that I have something to subtract from. That's going to give me 6. 9 minus 1 is 8. 6 minus 3 is 3. So 23 and 8600ths. Go back to my check. 23.86 plus 3.14 equals 27. Add those two together. I get 10. 10 carry the 1, 6, 7. A decimal comes straight down. 27 equals 27. Check. Our last one. Instead of adding 19 and subtracting 19, those go away. So I have P. 10 gives me a 9, so that's 6. 86 equals 86. 19 plus 86 equals 105. Add these two together. 15, 9, 10. 105 equals 105. Check. Guys, you see how easy this should become if you will follow the process. Circle your variable. Draw the line. The rest of it's easy. Go ahead and turn to our homework, page 421. Your journal. Write a definition in your own words. In other words, I don't expect to see a formal definition here. Read the definition and then tell me how you would talk about it to a friend. Okay?
Okay, so
On this one, you got two parts. Use a double number line to solve and check your solution. So then give me the equation. We did several of these in class today. Should be pretty easy. You got 4 of them. 3 on the first page, 1 on the second page. Directions there are the same. Second part is pretty open. Solve each equation. They didn't tell you how. I would recommend practicing the algorithm we just gave you. In other words, circle your variable, draw a line through the equal sign. You do that on every problem, it's going to show you what I need to do. You have 6 of those problems, and that's all your homework, guys. Any questions? Okay. Good luck.